equation is y prime plus the quantity of 1 plus 2x times y is equals to 1 over e raised to x squared. Transforming y prime to dy over dx plus the quantity of 1 plus 2x times y is equals to 1 over e raised to x squared. Now we have a linear equation. Getting the integrating factor v is equals to e times the integral of 1 plus 2x dx, translating u is equals to 1 plus 2x du is equals to 2 dx. Now du over 2 is equals to dx. Using this in the integrating factor, we have e to the 1/2 integral of u du. Now we have e to the 1/4 times 1 plus 2x squared. Multiplying this to the previous equation, we have dy over dx plus the quantity of 1 plus 2x times y is equals to 1 over e raised to x squared. Multiplying both sides by the integrating factor, e to the 1/4 times 1 plus 2x squared. Then d over dx times y to the 1/4 times 1 plus 2x squared is equals to 1 over e raised to x squared times e to the 1/4 times 1 plus 2x squared. Integrating both sides, and with dx here, we have y times e to the 1/4 times 1 plus the quantity 1 plus 2x squared is equals to e to the 1/4 times e to the x times e to the x squared over e to the x squared. On the right side of the equation, we can slash out e raised to x squared. So our new equation is y times e raised to 1/4 times 1 plus 4x plus 4x squared is equals to the integral of e to the 1/4 times e to the x times dx. Now, next is factoring out the e raised to 1/4 since it is constant. So, y times e raised to 1/4 plus x squared is equals to e to the 1/4 times the integral of e raised to x dx. So, y times e to the 1/4 plus x squared is equals to e to the 1/4 times e to the x plus c. Dividing both sides by e raised to 1/4 plus x squared, we have e raised to 1/4 plus x squared we have the new equation y is equals to e to the 1/4 times e to the x over e to the 1/4 times e to the x times e to the x squared plus c over e to the 1/4 plus 4 e to the 1/4 plus x squared. So slashing out e to the x and e to the 1/4, we have y is equals to 1 over e raised to x squared plus c times e to the negative 1/4 minus x squared. Now, given the condition y of 0 is equals to 3, now we can substitute these values to the previous equation. We have 3 is equals to 1 over e raised to 0 squared plus c times e raised to negative 1/4 minus 0 minus 0 squared. 3 is equals to 1 plus c over e raised to 1/4. Now, 2 is equals to c over e raised to 1/4, and cross multiplying we have c is equals to 2 times e raised to 1/4. Now, substituting the value of c to the previous equation, we have y is equals to 1 over e raised to x squared plus 2 times e raised to 1/4 time over e raised to 1/4 times e raised to x times e raised to x squared. And slashing out e to the 1/4, our new equation is ui is equals to 1 over e raised to x squared plus 2 over e raised to x plus x squared. Our equation is y prime minus y over x plus y squared over x is equals 0. Transforming y prime to dy over dx minus y over x plus y squared over x is equals to 0. Transferring these equations to the other side, we have dy over dx is equals to y over x minus y squared over x. Combining this into one equation, we have dy over dx is equals to over x y minus y squared. Now, combining like variables, we have dy over y minus y squared is equals to dx over x. Now we have a separable differential equation. Integrating both sides, we applying partial fractions in the left side of the equation, we have 1 over y times 1 minus y is equals to a over y plus b over 1 minus y. So, multiplying both sides by the denominator, y times 1 minus y, we have 1 is equals to a times 1 minus y plus by. We have a minus ay plus by. Now, combining like terms, we have minus ay plus by is equals to 0 and a, which is equals to 1. So, using the value of a in this equation, we have b is equals to a, where b is equals to 1. So, 1 over y plus 1 over 1 minus y, integrating both terms, dy and dy, we have ln y plus this equation is we let u is equals to 1 minus y du is equals to negative dy, where negative du is equals to dy. So transforming this plus sign into minus ln of 1 minus y is equals to the right side equation ln x plus c. Combining these two natural logarithmic equation into ln of y over 1 minus y is equals to ln x plus c. Applying e to both equations, we have e to the ln y over 1 minus y is equals to e ln x plus c. So we have y over 1 minus y is equals to x times e raised to c. Now, e raised to c can be represented as simply c. So replacing that term just gives us c. Cross multiplying both sides, we have y is equals to xc minus xyc. Combining like terms, we have y plus xcy is equals to xc. Factoring the y in this side, we have y times 1 plus xc is equals to xc. And dividing both sides by 1 plus xc, we have y is equals to xc over 1 plus xc. The equation is y prime is equals to the quantity of x minus y plus 1 squared plus x minus y. The problem with this is we have to show this equation is a separable equation by substituting the conditions. V is equals to ax plus by plus c. Now, first, transforming y prime into dy over dx is equals to, expanding this, we have x squared minus 2xy plus y squared plus 2x minus 2y plus 1 plus x minus y. Now, grouping the terms, we have x minus 2xy plus y squared. This plus 3 times x minus y plus 1. Further simplifying, we have x minus y squared plus 3 times x minus y plus 1. Now, we let v is equals to x minus y. So we have dv over dx is equals to 1 minus dy over dx. So, giving us dy over dx is equals to 1 minus dv over dx. Substituting this new equation to the previous equation, we have 1 minus dv over dx is equals to v squared plus 3v plus 1. Now, we have negative v squared minus 3v is equals to dv over dx. Combining and separating like variables, we have dv over negative v squared minus 3v is equals to dx. Now we have separable differential equation and integrating both sides where left side is applying partial fractions. 1 over v times negative v minus 3 is equals to a over v plus b over negative v minus 3, and multiplying both sides by this denominator v times negative v minus 3, we have 1 is equals to a times negative v minus 3 plus bv. Simplifying further, we have minus ab minus 3a plus bv. Combining like terms, we have bv minus av is equals to 0 and negative 3a is equals to 1. We have the value of a as negative 1/3, and substituting this value into this equation, we have b is equals to a, where b is equals to negative 1/3. From the partial fraction equation, a over v plus b over negative v minus 3, and with the values of a and b as negative 1/3, we have negative 1/3 over v plus negative 1/3 over negative v minus 3. Integrating both equation, then applying dv, we have negative 1/3 ln of v, and this equation letting u is equals to negative v minus 3, so we have du is equals to negative dv, where negative du is equals to dv. So plus 1/3 of ln of negative v minus 3, which is equals to x plus c. Multiplying both sides by 3 to eliminate this to eliminate fractions, we have negative ln v plus ln of negative v minus 3 is equals to 3x plus 3c. Combining these natural logarithmic equations into ln of negative v minus 3 over v is equals to 3x plus 3c. And applying e on both sides, we have e and e. So we have negative v minus 3 over v is equals to e to the 3x times e to the 3c. So, cross multiplying, we have negative v minus 3 is equals to v times e to the 3x, and representing this constant variable with c. So, combining like terms, we have v times e to the 3x plus v is equals to negative 3, and factoring out v, and plus 1 is equals to negative 3, and we have v is equals to negative 3 over e to the 3x c plus 1. So we have our new equation. Now recalling that v is equals to x minus y, so this value, so substituting to this variable, we have x minus y is equals to negative 3 over e to the 3x c plus 1. So now we have y is equals to x plus 3 over e to the 3x c plus 1. From the problem given, we have a sled which is 100 pounds and has a pushing force of 10 pounds. And it is pushed against the air resistance which has a magnitude of twice the velocity of the sled. Okay, so we have the Newton's second law of motion as the F total is equals to the summation of forces. And force is equals to mass times acceleration. So, where acceleration is the change in velocity over change in time. So, we have mass times change in velocity over change in time is equals to 10 minus the air resistance and the friction to V. From this, we multiply both sides by 1 over m. We have dv over dt is equals to 10 over m minus 2 over m times v. Now, we can see that we have a linear differential equation. So, transforming this, we have dv over dt plus 2 over m times v is equals to 10 over m. Now, we have, combining these two, we have m over 10 minus 2v. And factoring out the coefficient 2, we have 2 times 5 minus v over m.
So, yeah.
Now, from here, we can have a separable equation. So, dv over 5 minus v is equals to 2 over m times v. And integrating both sides, first, we let this side of the equation, we let the denominator 5 minus v equals to u. And du is equals to minus dv, where negative du is equals to dv. So, this is just the integral of du over u, and 2 over m is a constant, so we extract it out from the integral, and what's left is dt. So we have ln of u, which is equals to 5 minus v, is equals to 2 over m times t plus c. Now, our first question is, what would be the velocity if our time is equals to 0, which is equals to VO? So, from this previous equation, we substitute t is equal to 0. So, negative ln of 5 minus v is equals to 2 over m times 0 plus c. Substituting t with 0 gives us makes this 0. So the value of RC is equals to negative ln of 5 minus v. Now, since we substitute 0 to t, this becomes VO. Now, substituting the value of c to the previous equation, we have negative ln of 5 minus v is equals to 2 over m times t minus ln of 5 minus VO. Now, transferring this term into the other side, we have ln of 5 minus VO minus ln of 5 minus v. We have 2 over m times t. So, simplifying this, we have ln of 5 minus VO over 5 minus v is equals to 2 over m times t. And applying e to both sides, and we get 5 minus VO over 5 minus v is equals to e raised to 2 over m times t. So now we have Cross multiplying this, we get 5 minus VO over E raised to 2 over M times T is equals to 5 minus E. Since we want the velocity, so transposing 5 to the other side, we have V is equals to 5 minus 5 minus V over E raised to 2 over M times T. So we have the velocity. Now, simplifying further, particularly this denominator, 2 over ME. Now, M is so from the second law of motion, we have this. M is equals to force over acceleration, where force is equals to 100 over gravity. Now, substituting this to here, we have 2 over 100 over G times T, giving us GT over 50. Now, substituting this to E, we have V is equals to 5 minus VO times E to the negative GT over 50. The final equation for velocity. Now, second question is, what will be the distance covered by the sled if at the end of 1 second? So from this equation, now, we recall that V is equals to the change in distance over change of time. So we have d of dt is equals to 5 minus 5 minus VO times E raised to negative GT over 50. Now, cross multiplying, we get d of d is equals to 5 minus 5 the minus VO times E raised to negative GT over 50 times dt. Now, we integrate both sides, giving us distance is equals to integral of 5 dt minus the integral of 5 minus VO times E raised to negative GT over 5 dt. Now, from this equation, we have E is equals to 5t minus, now this is a constant, so we extract it out of the integral. So it's 5 minus VO times, now this we let U is equals to negative GT over 50, then du is equals to negative G over 50 dt. Simplifying further, we have G over negative G du is equals to dt. So now this is d is equals to 5t minus plus 5 minus VO times the integral, we have e to the negative GT over 50. Now, when time is equal to 1 second, the distance would be 5 plus 5 because VO starts from rest, so 0. VO times E to negative G over 50. This is the distance after 1 second. Now, this equation dy over dx is equals to lowercase ax plus lowercase by plus lowercase c over uppercase x plus uppercase by plus uppercase c. We have to prove that it's a separable differential equation with conditions v is equals to ax plus by if a is not equal to 0 And at the same time, v is equals to uppercase ax plus uppercase by if a is equals to 0. So first, we have to differentiate this v. So it's dv over dx is equals to a plus b dy over dx. Now transposing and we have the value of dy over dx equals to dv over dx minus a all over b. Substituting this value to this equation, now we have dv over dx minus a all over b is equals to ax plus by is v plus lowercase c over v plus uppercase c. Now, multiplying both sides by 1 over b, we have dv over dx minus a is equals to v plus lowercase c over b times v plus uppercase c. Now, from the condition given that v is equals to uppercase x plus uppercase by, where a is equals to 0, so substituting 0 to the equation a, we have dv over dx minus 0 is equals to b plus c over b times b plus c uppercase c. And now, we have to combine like variables and separate them. So we have dv times uh, b v plus uppercase c over v plus lowercase c is equals to dx. And simplifying further, we have b times b plus c over v plus uppercase c is equals to dx. Simplifying further, we have b times v plus uppercase c over v plus lowercase c dv is equals to dx. So as we can see, v is in the dv and we have dx. So we can say that this equation is a separable differential equation.